If you are in, you can comment and say you are in. Catherine, I can see you are present. Hello everyone, I hope you are doing well, my learners. In this lesson, we'll be learning on indices. We'll be learning on indices. And indices it is a topic in Form 2. Indices is a topic in Form 2, which simply means, so indices is a plural of index. Is a plural of index. Indices is a plural of index. And what an index is in mathematics, an index is also known as power. It is also known as exponent, and it can also be called a logarithm of a number. A logarithm of a number. So an index is also known as a power, an exponent, or what we call a logarithm of a number. So the reason why it is very, very important for us to learn indices is because in our day-to-day activities or in our daily lives, we tend to interact with numbers which cannot probably be written as they are, but through the concept of indices, we can be able to write those numbers in a more simplified manner. For instance, if we have, allow me to have a real life example. And in this real life example, for instance, the speed of light is equivalent to 3.0 times 10 to power 8 meters per second. 3.0 times 8 times 10 to power 8 meters per second. So this simply means that this number here, 3.0 times 10 to power 8, has been written in standard form, which is more easier to write this number in this form, overwriting this number as 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. So it's more easier writing this number as 3.0 times 10 to power 8 than writing this number as, this is 300 million meters per second. So it's easier to say 3.0 times 10 to power 8 meters per second than saying 300 million meters per second. So when we are dealing with numbers, we will learn that powers are very, very important. So when we talk of powers or the index, as we have said, indices is a plural of index. So don't overthink on where the term indices came from. It is a plural of index, and we have said that an index is an exponent, it is a power of a number, or it is the logarithm of a number. So let us have some numbers here, and in these numbers we have a number like 32, and that is our number 1. Our number 2, we can have 27, and in these two numbers I want us to express them in power form. I want us to, we express the numbers in index form. We express the numbers in index form. So how do we go about expressing the numbers in index form? So this is what we do. This is what we do for us to express the number in index form. We take the first number, which is 32, and we factorize 32. We factorize 32 in what we call, we write it in the product of its own factors. So 32, the smallest or the greatest common divisor of 32 is 2, which will give us 16. By 2, it will give us 8. By 2, it will give us 4. Then that 4 by 2, it will give us a 2. And by a 2, it will give us 1. So we will end up having 32 is equal to, let me write it here, 32 is equal to 2 times 2 times 2 times 2 times 2 times 2 times 2. And once we have that, how many 2 do we have here? We have 5 2s. 1, 2, 3, 4, 5. So we can write it as 2 to power 5. So 2 to power 5 is the number written in index form. Index is power form. Power is written here. So let's express the second one, 27. 27. Number 2 is 27. So 27, the greatest common divisor of 27 is 3, which will give us a 9. A 3 will give us a 3, and a 3 will give us a 1. Therefore, 27 is equal to 3 times 3 times 3. 3 times 3 times 3. And therefore, 27 will be equivalent to 3 times 3 times 3 is the same as 3 to power 3. So 27 written in power form is 3 to power 3. 3 to power 3. We are still laying the foundation on indices. Remember, these questions are commonly assessed in Mathematics Paper 1, Section 1, and I want us to learn on how to go through these questions because they are commonly asked, that is in Section 1, and I don't think there is any value getting all questions in Section 2 right and missing the concepts in Section A. Remember, as much as we emphasize more on passing the 10-mark questions in Section 2, remember both sections carry the same weight. Section 2 carries 50 marks and Section 1 carries 50 marks. So I'm trying to guide you on how you can be able to diversify your risk in performance by teaching you some of the commonly assessed questions. That is in Mathematics Paper 1, Section 1. So having that, if you can recall, the first question that we have responded to was 27. Sorry, it was 32, which was equivalent to 2 to power 5. So 2 to power 5, this number 2 to power 5 is written in form of a to power n. Is written in form of a to power m or to power n, where A is the base and M is the index. A is the base where M is the power, or what we call the index. So when we have 2 to power 5, it means our base is 2 and our power stroke our index is equal to 5. You can list for me the base and the power of 27. 27, we saw it is 3 to power 3. So what will the base be and what will the power be? You can list that down on the comment section. List that one down on the comment section. 3 to power 3. What will be the base and what will be the power or the index? List that down on the comment section. So respond to that. Correct. Agwet. Base is 3 and power is 3. Catherine, 3 is the base and 3 is the power. Elvis, the same. I cannot see Jelly Jogona. Oh, I am seeing Jelly Jogona in. Where are they? I hope everyone will be back. Power 3 hiyo hapo juu. Correct. That's good. Let us continue. I want us now to proceed to laws of indices. This is very, very important. Laws of indices. Laws of indices. Wacha hata niandike hapa juu, nifute hii ya kwanza, niandike hapa. Laws of indices. Laws of indices. Laws of indices. Laws of indices. So in laws of indices, we will start with the first law, which we call the multiplication law. We call this one the multiplication law. We call it the multiplication law. And in the multiplication law, it simply states that a to power m times a to power n is equal to a to power m plus n. I want to demystify on this. A to power m times a to power n is equal to a to power m plus n. When the base is the same and we are multiplying, the answer to that, we add the powers. We add the powers. So what we are going to do is that a to power m times a to power n is equal to a to power m plus n. So what we are going to do, we will now take, we can now have an example. if we have a number like 2 to power 4 times 2 to power 3, our answer will be 2 to power 4 plus 3. 2 to power 4 plus 3. And 2 to power 4 plus 3 will end up giving us 2 to power 4 times 2 to power 3. It will give us 2 to power 4 plus 3 is 7. That is the multiplication law. That is the multiplication law. That is the multiplication law. We can have some more examples on multiplication law. We can have some more and more examples on multiplication law. Y to power 6, example 2. Y to power 6 times y to power 5. Y to power 6 times y to power 5. So when the base is the same and we are multiplying, our answer will be base remains the same y, then we add the powers 6 plus 5. So we will get y to power 6 plus 5 is 11. And we are done. And we are done. And we are done. Example 3. If we have 2m to power 7 times 3m to power 4. 2m to power 7 times 3m to power 4. How do we respond to that? Check here. We have two variables. We have different variables. We have the constants 2 and 3, and we have the m's. So what does this mean? This simply means this is the same as saying 2 times m to power 7. I want you to understand that 2 times m to power 7. For us to get 2m to power 7, it was 2 times m to power 7 times 3 times m to power 4. Like that is equal to, so for us to solve that one, what we are going to do, we will take the constant we multiply. 2 times 3 is equal to 6. Then we take m times 7, m to power 7 times m to power 7 times m to power 4. So that will be equal to 6 m to power 7 times m to power 4. It will be equal to m to power 7 plus 4 is 11. Is 11. Is 11. So that is how we solve that one. Another question on multiplication law that we can have is r to power 5 times r to power 2m times r to power n. We can have that as a point of reference. And remember, we have said when the base is the same and we are multiplying, so our results r will remain. Then we will add the powers. 5 plus 2m plus n, and I think just by the look, that one we will leave it like that, because 5, 2m and n are not like terms, they are unlike terms, so we cannot add them, we'll just leave it like that. So generally, that is how we respond to questions on multiplication law. Multiplication law. That is how we respond to questions on multiplication law. Let us continue. So answer this question. Solve the following. 2 to power 3 times 2 to power 7. 2 to power 3 times 2 to power 7. That is number 1. Number 2, that we can also respond to, is 3 to power k times 3 to power 3k. Can try to respond to those two questions. Respond and give me the response. Then we will now proceed to division law after you are done with that. Let us first speak on multiplication law. Respond to those two questions and give me the feedback. I'm waiting. I'm waiting for your feedback. Base 2 power 10. That is Catherine, correct. This one is equal to base 2 power 10. The next one, Rahab Wambui, Jerry Jogona, 2 power 10, correct. Correct, Jerry Jogona. I can see everybody is in. To maintain hivyo, hiyo hao watu 7 msitoke. Jerry Njogona, 3 power 4. 3 power 4, no. Nelson, base 3 power 4k, correct. Nelson, base 3 power 4k is correct. Agwet, 2 power 10, correct. 3 power 4k, that is correct. Catherine, base 3 power 4k is correct. Yes. Jelly Jogona. 3 power 4. It should be 3 power 4k. I can see you are all correct. Let us do some more examples. The reason I edited division back to multiplication is because I feel there are still some more examples that we need to do. So we can have a question here. Solve the following. 2 to power 2x plus 2 times 4 to power x plus 1 is equal to 8 to power x. I want us to respond to such a question. Mark Elvis, 3 power 4k, correct Elvis? So I want us to respond to that question. So wakati umepata swali kama hili 2, 4, 8. The first thing you need to do, you need to check out your lowest number, the smallest base, which is 2. So our smallest base is 2 here. And when we get our smallest base as 2 here, we are going to check out whether the other numbers can be written to base 2. So if the other numbers can be written to base 2, we will write our equation, all of it in base 2. And how do we go about that? This already is in base 2. So it will be 2 to power 2x plus 2 times 4 can be written to base 2. So it is going to be 2 to power 2. 2 to power 2 into bracket x plus 1. 2 to power 2. Remember 2 to power 2 is 4. 2 times 2 is 4. Is equal to 8 can be written to base 2. So it will be 2 to power 3 then x. 2 to power 3 x. 2 to power 3 x. So what we are now going to do here, we will now open our brackets, that is for the powers, and have 2 to power 2x plus 2 times, this will remain as 2. Then let's use this power to multiply. Why are we multiplying? Because we can work out the powers as they are. So 2 times x will be equal to 2x. So only 2 to power 2x plus 2 times 1 is 2 is equal to 2 to power 3x. 2 to power 3x. 2 to power 3x. And from here, you can now see clearly that all our bases are 2. Our base is 2. And once we get our base as 2, what we are going to do is that we have the liberty to drop the base. So you will drop the bases. So here we will drop base 2. By saying drop base 2, tunaachana na 2, tuna solve powers peke yake. So tutachukua 2x plus 2. Then this multiplication, remember, we said it is addition. When we have bases the same when we are multiplying, so the powers we add. So it is plus 2x plus 2. Then we have the other side is equal to 3x. Is equal to 3x. So we are now solving the power. We have dropped the base. We have dropped the base. So that will be 2x plus 2. Then we add here plus 2x plus 2 is equal to 3x. Is equal to 3x. And once we do that, we will now work this one out to have 2x plus 2x is 4x. 2 plus 2 is 4 is equal to 3x. So what we will now do, we will now put the right terms together. So we will bring this to this side and take positive 4 to the other side. So we will have 4x minus, this one is plus, so when it comes to this side it will be minus 3x is equal to, this is positive 4, once it goes to the other side of the equal sign it will be negative. So 4x minus 3x is equal to x, and our x will be equivalent to negative 4. Our x will be equivalent to negative 4. And by doing that, we are good to go. We are good to go. We are good to go. So let's have another example. Do this one. Or we can do this one. Then I'll give you one and you give me the feedback. So we have 3 to power x, or let me say 3 to power k multiplied by 9 to power x minus 2 is equal to, sorry, not x, k minus 2 is equals to 9 to power k plus 4. So in that question, I want you to, we are going to solve for k. We will solve for k. We will solve for k. In that question, we will solve for k. We will solve for k. So for us to solve for k, we said we check out the smallest base that we have, and the smallest base that we have here is 3. So we will ask ourselves, can the other bases be written in to base 3? Yes. 9 is a factor of 3, and also this 9 is a factor of 3. So what we are going to do, we are going to write them in form of, we write them to base 3. So this one will remain to be 3 to power k times 9 is the same as 3 squared. So it is 3 to power 2, then k minus 2. So 3 to power 2 is 9. We have replaced 9 with 3 to power 2 is equals to the same here, 3 to power 2 k plus 4. K plus 4. So by doing that, can lab this part and utilize this space here. And once we do that, we are going to have 3 to power k multiplied by 3. We now work out the powers. 2 times k is 2k minus 2 times 2 is 4 is equals to 3 to power 2 times k is 2k plus 2 times 4 is 8. So this one is k, 2k plus 8. So once we have that, we now have all our bases as 3. We have our bases as 3. We can now drop base 3. We can drop base 3. Don't cancel, just drop them. Hata si lazima uandike drop base 3. You can just leave them and proceed solving the powers. So we will now take k. Because we have multiplication here, the power we will now add the powers plus, that is 2k minus 4 is equal to 2k plus 8. 2k plus 8. So this one will be k plus 2k minus 4 is equals to 2k plus 8. The reason I'm putting a bracket here, I prefer putting a bracket because, for instance, if we have a minus and you don't put a bracket, you only subtract one value and you don't subtract this, so you end up getting wrong. Every time you are adding or subtracting a compound number is a number that is made up of more than 2 variables. Ensure that you either add in a bracket or subtract in a bracket. Even if it will remain the same, For addition, majority of the cases it remains the same, but for subtraction, and we have a subtraction here, a negative times a negative becomes a positive. So take note of that. So by doing this, we will get, we now put the right terms together. K plus 2k, that is equal to 3k, minus 4 is equals to 2k plus 8. So we will put k on one side and take negative 4 to the other side. And by doing so, we will have 3k minus 2k is equals to 8 plus 4. And 3k minus 2k is equal to k, which is equal to 8 plus 4, 12. So 12 is the answer for that. Yes, LV's k is equal to 12. That is correct. K is equal to 12. K is equal to 12. That is correct. I don't know where people are going. I'm seeing only 2 people in class. Elvis is in. I don't know the other person who is in, but I can only see 2. So let's proceed. Let me give you a question. Let me give you a question here. So solve this one, and once you solve this one, we'll now get to division law. Division law. Tuendelea kwa division law. So respond to this. Solve for t. 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 Fanya hiyo, unipatie feedback. Do that one and give me the response. Send your response. Send your answers. Toti Kamanga, Mark Elvis, naona mmetuma. Wacha kila mtu atume tujue jibu ni gani. Send your responses. Guet 2, Mark Elvis 2, Toti Kamanga 2. Tuendelee kutuma. Tutume. So 2 is correct. 2 is the answer to that. 2 is the answer to that. Two is the answer to that. Who else has not sent her response? Nelson 2, correct. Rahabo Amboi 2, correct. That's correct. Let's ensure that we are all in class so that we will flow together. So let us continue with no. So let's respond to this question. I've seen you have understood it clearly that all these numbers can be written to base 3. Even if I didn't include 3 as part of the basis, you have known that all these numbers can be written to base 3. Why? because 9 being the lowest base here, 9 is not a factor of 27. So you must go down to base 3. So this gave you 3 to power 3, t minus 3, multiplied by 3 to power 2, 2t is equals to 3 to power 5. So by dropping the base, you will get 3t minus 9 plus 4t is equals to 5. Then by putting the right terms together, you got 3t plus 4t is 7t is equals to 5 plus 9 is 14. And by dividing both sides by 7, you got your TS2. You got your TS2. So that is correct. So let's get down to division law. Division law. Division law, the formula is a to power m divided by a to power n is equals to a to power n minus n. This is the opposite of multiplication. In division, when we have two numbers to which the base is the same and we are dividing the two numbers, the base remains the same, but we subtract the powers, we get the difference between the powers. So that simply means if we have a number like 5 to power 4 divide by 5 to power 3, that will be equal to 5 to power 4 minus 3, which will result in 5 to power 1. 5 to power 1. That will result to 5 to power 1. It will result to 5 to power 1. Let's have another example. If we have a number 15k to power 4 divided by 5k to power 2. If we have such a number, what is going to be our solution? We are going to know, we need to understand that these two numbers, 15k to power 4, has been obtained from 15 times k to power 4. Then we divide 5 times k to power 2. Then we find the solution. So 15 divided by 5 will be equal to 3. Then into brackets, k to power 4 divided by k to power 2. K to power 4 divided by k to power 2. So our response will be 3 to power 3k to power 4 minus 2 is 2. That is 3k squared. That will be our response, 3k squared. Our response will be 3k squared. And probably respond to this. $25 m to power 12 divided by 5 m to power 7, and you can also respond to 19 to power 14 divided by 19 to power m. Respond to those two questions. Esther, Agwet, 5m power 5. The first one, 5m power 5, correct. Catherine, 5m power 5 is correct. Nelson, 5m power 5 is correct. Five m power 5, Njeli Njuguna, it is correct. Njeli Njuguna, where is Esther? Esther anajiita aje huku? So 5m power 5 is correct. Give me the response to the second question. Give me the response of to the second question. Mark Elvis, 5m power 5 is correct. And I think you can use a red pen. Use a red pen to mark it on your book. Use a red pen to mark it on your book. Esther, where is Esther? Njeli Njuguna. I respond to the second question. Respond to the second question. 19 to power 14 divided by 19 to power m. Are you done? Yes, call her please. Follow up on why she is not in. I don't know the reason behind. Okay. Jibu la Roman 2. Roman 2. One power. Mark Elvis. 1 power 14 minus m. Is it 1 or 19? Is it 1 or 19? Jibu la pili. Haya, hiyo mtanitumia baadaye. Ama tu mtalituma hapa nitaliona. I can see your response clearly. Let's proceed to the next law. before yes, let's proceed. We have some questions here. And the first question is, solve for it. In the equation. Solve for it in the equation. So this one is a combination of multiplication and division law. It is 32 to power x minus 3 times 8 to power x plus 4 is equal to 64 divided by 2 to power x. 3 marks. This was a KCSE question. I want us to respond to that question. We are dropping the base ama tunaacha hiyo? In which question? Catherine, hiyo nimefuta ama? So I want us to answer this question together. Catherine, we are dropping the base ama tunaacha hivyo? That is a question for which question? Oh, hiyo hiyo 19 lazima si ilikuwa, I think it was 19 to power 14 divided by 19 to power m. Tulikuwa to simplify. So ingekuwa 19 to power 14 minus m. Ingekuwa hivyo. 19 to power 14 minus m. So let's proceed with this one. So let's respond to this question. The smallest number here is 2 as the base. So what we are going to do is that we write all these numbers to base 2. So 32 to base 2 is 2 to power 5 x minus 3 times 8 is 2 to power 3 x plus 4 is equals to 64 is 2 to power 6 divided by 2 to power x. That is the first step. So we will now get 2 to power 5x minus 5 times 3 is 15 times 2 to power 3 times x is 3x plus 12 is equals to 2 to power 6, then divide by 2 to power 2. So by having that, we can now drop our bases, and once we drop our bases, we will have 5x minus 15. Because we are multiplying here, we will add 3x plus 12 is equals to, here we drop 2 and we will be left with 6 minus sorry, 6 minus x. We'll be left with 6 minus x. Why 6 minus x? Because here it is a division. So it is not a must you have a separate question on multiplication and division. Both of them can be incorporated within one question, and you can be expected to solve such. So let's proceed that in this particular part. So 5x minus 15, hata mbona najirudia. So itakuwa 5x minus 15 plus, open the bracket, 3x plus 12 is equals to 6 minus x. So in this case, you are going to, can you on comments? Catherine, concerning dropping the base, we drop the base when it is the same. Listen, dropping the base comes in when we are solving. You see, we have an equals sign. We are dropping because we are solving an unknown in the power. That is why we are dropping. We have a difference. We have a difference between an equation. Let me explain that. Wacha tumalize hii alafu nielezee hiyo. So 5x plus 3x is equal to 8x. 5x plus 3x is equal to 8x. Then minus 15 plus 12. Minus 15 plus 12. That will be equal to minus 3. Is equal to 6 minus x. Then let's put the right terms together. We will bring this minus x on this side and have 8x plus x is equals to, we take this to the other side and have 6 minus 3 on the other side will become plus 3, and this will give us 8x plus x is 9x is equals to 9. 6 plus 3 is 9. So we will divide both sides by 9 and we'll end up getting our x as 1. Our x as 1. So let me respond to that, Catherine, so that you can understand. I hope you are done. Listen, in mathematics we have what we call an equation and we have what we call an expression. For instance, if we have 2x plus 4 is equal to 8, this is an equation. But if we have 2x plus 4 just like that, is what we call an expression. So we need to know how to differentiate an equation with an expression. An equation is accompanied by an equal sign, which simply means whatever is on the left hand side is equal to what is on the right hand side. So in this case, in indices, that is why we are dropping the base to solve the powers. But when we have an expression, a good example, we had 19 to power 14 divided by 19 to power m. There was no equal sign here. And it is not just having an equal sign, it is having another value on the other side of the equal sign. So this one is an expression. So the only way you can work out an expression is by simplifying. You work out an expression by simplifying. And how do you simplify that? You know the base remains the same and the power is 14 minus m. 14 minus m. But if your question was like this, so that question was on simplifying. If our question was like 19 to power 14 divided by 19 to power m is equal to 19 to power 1, that in that case we would have dropped the base 19 to back in a 14 minus m is equal to 1. Hapa tunge drop. Kwa nini? Because this one now is an equation. Then we now solve m and find our m, as our m here would have been, if we take this to the other side, our m would have been 13 in this case, because this goes there and this comes here, so our m would be equal to 13. So I want you to understand that simplifying, there is no equal sign, you write it in more simpler terms, but equation, you must drop the base to solve. Have you understood? Has everyone understood? Thank you, Catherine, for that question. Before I write down the second question, anyone with a question? You can ask a question now. You can ask a question. Kelvis one, correct? Anyone else with a question? Who else has a question? Tuko sawa? Kama tuko sawa niambieni. Tuko sawa? Ili tuendelee, niwapatie swali lingine mfanye. Then we proceed with the next row. Are we okay? Mpaka hapo tumefika. It is only Esther who is behind. Na nimeambiwa anafuatilia bado. So tuko sawa mahali tumefika? Yes, Jerry Njogona, yes. Kila mtu nipeni feedback tafadhali. Haya, simuache niwapatie swali hapa basi, mkiendelea kufanya. Na swali liko hapa. Solve for x in the equation. (81 to power 2x times 27 to power x over 9 to power x is equal to 729. 3 marks. Fanya hiyo. Na pia ufanye hili lingine. Ya kwanza fanya hilo, unipatie jibu. Fanya hiyo, nipatie jibu. Let me write another one. Do that one. Both of them. Mark Elvis 11/12. That is long. Mark Elvis. Rudia tena. 11/12 Mark Elvis. Not correct. Catherine 2/3. Correct. Correct, Catherine. Question 2. Who is done? Jelly Njogona. Catherine, the second question, why being sits, it's long. It is long. Nelson, 2/3. Mark Elvis, question 2, why is it long? Tuti Kamanga, question 2 is long. Aguat, waiting for your response in question 2. Let's proceed to this question. A majority of us have failed. Majority of us have failed this question. Let's solve it together. Na mtaona ni wapi mmekosea. I know where you have gone wrong. I know. The reason why I know where you went wrong is because when I was a student like you, I also failed this question not once, not twice, not thrice, until I saw where my mistake was. So listen and listen carefully. This is when I tell you sign matters. Sign matters. So 243, I hope we can write it more simplified. 243 is the same as 3 to power 5 times 3 to power 2y over 729 is 3 to power 6 times 3 to power y divided by 3 to power 2y minus 1, then is equals to 81 is 3 to power 4. Wacha tuanze hapo. So we can simplify the numerator. The numerator itakuwa 3 to power. When we have multiplication, we add the powers. So the power will be 5 plus 2y over the denominator. We have, tuchukue hizi mbili kwanza, itakuwa 3 to power 6 plus y, then divide by 3 to power 2y minus 1. It's like that, is equals to 3 to power 4. So iko hivyo. So far tumefika hapo. Tufute hii part ya juu, tuendelee hapa. So tukifanya hivyo, this one here ukiangalia vizuri, zote ziko to base 3. Zote ziko to base 3. So to make things easier hapa, tunafaa kujua hapa kuna over. So hii over ni division. Na hii division kuna minus hapa. So we can arrange it this way. Tunaweza arrange kwa imeenda hivyo, 3 to power 5 plus 2y divide by, tuna divide yote, 3 to power 6 plus y divide by 3 to power 2y minus 1 close the bracket is equal to 3 to power 4. Iko hivyo. So tufute hapa. The reason unaona nikiweka hizi brackets zote ni kwa sababu there is a secret that lies behind these brackets. So tukifanya hivyo, tuondoe, let's drop the bases, tuachane na bases to deal na powers. So tutakuwa na 5 plus 2y minus, tuko na bracket kubwa ya denominator yote ambayo ni 6 plus y, lakini hii ni minus hapa pia. Hapa tuna subtract hii yote. So inafaa iwe minus 2y minus 1. Then tufunge yote is equals to 4. Shida ni nyinyi wengi, najua mme subtract hapa, hamjaweka brackets, mmeiacha hivyo. Mlikuja mkaiacha hivyo. Ukiacha hivyo umesubtract hii moja peke yake. But unafaa ikuwe na bracket ili hii subtraction subtract kila kitu. So ikiwa hivyo itakuwa 5 plus 2y minus, hii usikuwe na haraka nayo, juu huwezi solve hii ya kwanza, bracket ya kwanza kama hujasolve hii ya pili. So itakuwa into bracket 6 plus y, tufungue hapa, minus negative times 2 is minus 2y, negative times negative 1 will be plus 1. It will be plus 1, then tufunge is equal to 4. Plus 1 is equal to 4. So hapa tuko na 5 plus 2y minus, tuweke tu hivyo kwanza, tuweke right terms together. 6 plus 1 ni 7, then y minus 2y is negative y, then is equal to 4. So tukiwa na hiyo sasa tunaweza fungua na hii bracket ingine. So tunaweza fungua na hii ingine, so itakuwa 5 plus 2y minus 7, then minus minus will be plus y is equal to 4. Then put the right terms together. 2y plus y is equal to 3y. 5 minus 7 is equals to negative 2 is equal to 4. Then we take negative 2 to the other side of the equal sign. We will have 3y is equal to 4 plus 2, which is equivalent to 6. So 3y is equals to 6. Having 3y is equal to 6, we divide both sides by 3, and we will get our y as 2. 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 Nani ana swali? I hope mumeelewa. I hope you have seen where you went wrong. I hope you have seen where you made a mistake. Umeona kosea wapi? Tell me where you made a mistake. I hope you have understood. If you have understood, just comment yes, so that I can proceed to do the next thing. But I don't want to proceed alone. I want to proceed with you having understood what we are doing. So kindly, please ensure that Mark Elvis, you have understood. Yes, that's good. Nani mwingine ameelewa? Aguet, yes. Aguet, yes. Totikamanga, yes. Nani mwingine? Nelson Yetau, yes. You've understood. That's good. Mtu mwingine Jalinjogona, yes. Umeelewa? Mumeona mahali mlikosea? Okay. Mahali uko na subtraction na una subtract a compound number, uwekange brackets tafadhali. If you don't put a bracket, you will end up getting it wrong. So ensure every time you are subtracting a compound number with a subtraction sign or a negative number, always put a bracket so that you subtract every variable in the compound number. So tumeelewa sote? Naona tuko sawa. Haya, kama tuko sawa, hizi rows ndizo main, multiplication and division. Kuna ingine nataka tufanye, kuna maswali nataka tufanye hapa. What if the base is not the same? Ama what if we don't have kuna namba moja haina common base? How do we go about it? Nataka tufanye kama hiyo. Hizo rows zingine bado tutazifanya tu, but hizi ndizo zimebeba weights. Majority of the questions zenye huulizwa, they come from these two rows and they come from the a compounded version of these two rows on multiplication and division. So for now, let's do another question. If the powers are a little bit different, wacha tuangalie kama hii. Solve the equation. Solve the equation. 9 to power 8 plus 1. 9 to power 8 plus 1. Niandike 9 vizuri. 9 to power 8 plus 1. Haya. Plus 3 to power 2 8 plus 1 is equal to 36. Is equal to 36. I remember Lahabombo, yes. I remember back in primary school tungepatana na swali ambaro lilikuwa 2 minus 4. Tulikuwa tunasema it is impossible. It is impossible. Na mwalimu anatuambia, children, you are right. Pupils, you are correct. It is impossible. So we used to borrow. But now, getting to high school, you learned that 2 minus 4 is negative 2. So it now became possible. So whatever we were told is impossible, we were now told it's possible. But it is not because the primary school teacher was wrong. The reason why the teacher said it is impossible because the scope of study or what you are to cover back in primary school was just impossible thing. But now in high school, we are now working more on the possibility. Why am I gravitating towards that real life situation? The reason I'm doing that is because now we have another case here. 9 to power 8 minus 1, sorry, 9 to power 8 plus 1 plus, this is plus, hapa hakuna multiplication, plus 3 to power 2 8 plus 1 is equals to 36. So uulizwe swali kama hilo, and that question, wacha niandike marks zake. That question has 3 marks. That question has 3 marks. So my question is, how do we navigate through such a question? Kitu ya kwanza tunaangalia kwa hizi namba ziko hapa, ni namba gani ziko. We have 3 as our smallest base and 9 can be written to base 3. So that is the first thing we are going to do. We are going to write this equation to base 3. So 9 is the same as 3 to power 2 8 plus 1 plus 3 to power 2 8 plus 1 is equals to 36. To base 3 haiwezekani. Now this one is not possible, and if it is not possible, don't force issues. Wewe yeke hivyo, usiforce issues, unaiacha tu hivyo. Ukiacha hivyo, to open brackets hapa, so itakuwa 3 to power 2 times 8 is 2x plus 2 times 1 is 2 plus 3 to power 2x plus 1 is equals to 36. Sasa hapa ujue huwezi kuja useme ati drop base 3. Hapa hakuna base 3. In this case you cannot drop. Why? Because we don't have 36 being written as base 3. So ikiwa hivyo, what we do here is tunafaa to split hii, tutoanishe hii, na kutoanisha hii, kama hapa kuna 2x plus 2, kumbuka from multiplication law tulisema a to power m plus n is equal to a to power m times a to power n. Si ndivyo tulisema kwa multiplication law? Hii tulisoma, ndio tulianza nayo. So tutatumia hii kuandika hizi from this way to this way, kumaanisha 3 to power 2x plus 2 ni the same na 3 to power 2x times 3 to power 2. So tukizilewrite hivyo, nayo ya pili itakuwa hii, nayo pia tuiandike hivyo. So hii direct pia itakuwa 3 to power 2x times 3 to power 1. Tukifanya hivyo, tutafuta hapa, tuendelee. So tukifuta hapa itakuwa 3 to power 2x times 3 to power 2. Hiyo ni hiyo ilikuwa ya kwanza. 3 to power 2x plus 2 ni the same na hii, plus 3 to power 2x times 3 to power 1 is equal to 36. So tutakuwa na hiyo sasa. Tukiwa na hiyo, what we are going to do, we will create a problem to solve a problem. Listen, we will create a problem to solve a problem. So once we create a problem to solve a problem, after we solve that problem, we will now solve the problem. Am I making sense? In this case, we will create a problem to solve a problem. And after we solve that problem, we will use the solution to solve the initial problem that we created. How do we go about that? Hapa tuko na 3 to power 2x na tuko na 3 to power 2x. Hizi mbili zinafanana. Na kwa sababu hizi mbili zinafanana, we can come and say let 3 to power 2x be k. Let 3 to power 2x be k. And once 3 to power 2x is equal to k, what we are going to do now is we will replace 3 to power 2x tuweke k. Mahali kuna 3 to power 2x tuweke k. So tukuje hapa ikue k times 3 squared ni 9 plus k, remember k is 3 to power 2x times 3 to power 1 is 3 is equals to 36. Is equals to 36. Then tuendelee kusolve. K times 9 is 9k plus k times 3 is 3k, which is equal to 36. So 9k plus 3k is 12k, which is equal to 36. For us to get k, we will now divide both sides by 12 by 12, and once we simplify, we will get our k as 36 divided by 12 is 3. Is 3. So we created a problem to solve a problem. Now because we have solved a problem, we now need to use this solution to solve our initial problem, which was x. So we will now say, we said let 3 to power 2x be k. Na tushapata k yetu ni 3. So itakuwa 3 to power 2x is equals to, our k is 3 to power 1. Remember 3 can be written in form of 3 to power 1. So 3 is the same as 3 to power 1 because 3 to power 1 is 3. So after doing that, for us now to solve, we will now drop base 3. After dropping base 3, we will have 2x is equals to 1, and we will divide both sides by 2, and we will get our x as a half, and we are done. Tumemaliza. That is how we go about it. You create a problem to solve a problem. Once you get a solution, you use that solution to solve the initial problem. Ask a question. Haya. Wacheni niwapatie kama hiyo. Kamoja tu ka 4 marks. I hope mmemaliza kuandika. Are you done writing? If you are done writing, say yes, so that I can lab this. I believe that provided you are following, you can see. Fanyeni hii mnipe jibu. Hii mtapata. Hii si washtue, hii mtapata. That's why sitaki kuwakimbiza sana. I want to teach you the exam. There is what we call the art of teaching, the art of passing exam, and the art of teaching exam. What I'm teaching you exams. It is not a matter of completing the syllabus. It's a matter of doing the right thing. So, do this question. Find the value of x, or solve the equation. 4 marks. By solving, you know you are finding the unknown. Hiyo ambayo unaita unknown ndo unatafuta. 49 to power x plus 1. 49 to power x plus 1 plus 7 to power 2x is equal to 350. Is equal to 350. Fanya hiyo mbio mbio. Fanya hiyo mbio mbio. Teke unipatie jibu. Ha? Who is done? Who is done? Where are you? Where are you? Kama umemaliza Tuma jibu lako. Who is done? I got 1/8 Haya. As you will be doing that question, you will send me the feedback. Law number 3 is the fractional law. The fraction law, fractional indices. And fractional indices, we mean Jerry Jogona 6.25 long. Not correct. So fractional indices, we have the law inasemanga a to power m over n. Acha niandike vizuri. Law husema a to power m over n is the same as nth root of a to power m. A to power m over n is the same as nth root of a to power m. Nth root of a to power m. Nth root of a to power m. If we have a question here, 9 to power a half. 9 to power a half. 9 to power a half is the same as, we find the square root of 9. I hope you know the second root. The second root is the same as square root. So when we have root 2, here, when we have the 2th root of the second root, that is the same as the square root. So it is the square root of 9 multiplied by 1. So square root of 9 is 3, and 3 to power 1 is equal to 3. 3 to power 1 is equal to 3. 3 to power 1 is equal to 3. Another example, we can have 32 to power 2 over 5. 32 to power 2 over 5. 32 to power 2 over 5. So what this means is that we are supposed to find the fifth root of 32, then we raise to power 2. The fifth root of 32, then you raise to power 2. So to find the fifth root, let me guide you using a calculator instead of using the factorization method. So for you to find the fifth root of a number, you click on your calculator shift, then raise, then that number 5. Ukifanya hivyo itakuletea kakitu kanakaa hivyo. So unataka tufanye hivyo kutumia calculator. Nitaweka calculator kwa kamera vizuri uone. So it is shift, I hope you can see. Tutafanya shift, then tufinye raise iko hapa hivi. No, sorry. Tutaanza na shift. Tutaanza na 5. Tutaanza na 5. Then shift. Then raise, hiyo sign ya raise kwa calculator. Tukifanya hivyo itatupatia kitu inakaa hivi. So tufanye hivyo. Tutakuja hapa tuseme 5, then shift, raise, just a minute, then 32 itupatie 2. Wacha turudie tena. Tutafinya 5, then shift, then raise, then tuweke 32 itatupatia 2. So ikitupatia 2, so itakuwa 2 to power 2, which is equal to 4. 2 to power 2 is equal to 4. And by doing that, nataka unifanyie hili 8 to power 2 over 3. 8 to power 2 over 3. Nifanyie hiyo 8 to power 2 over 3. Unipatie jibu hapa. Mumemaliza lile la kwanza? Yes, that is correct. Elvis and Aguat. Haya, taachia hapo. Hata mmejaribu sana hiyo mmejaribu. So this will mark the end of our lesson. Let's meet in our next lesson. I'm going to send you some assignment on this. Have a good day.